So hello everyone, welcome to this good morning for Tunisian people, because in Tunisia this is the morning. You are happy to organize this new session, which is part of the data science from Zero to Hero series. So this is the second session, and you are so pleased to be hosting Hafedh today. Let me just, so I'm from PyLadies Tunis team. So PyLadies Tunis is just a network of passionate women about, the group is composed of 3 women passionate about programming with Python, and you represent a network of Python users in Tunisia, not only limited to women. And you are part of a global community. This is the PyLadies global community, which focuses mainly on helping more women become active participants in the Python open source community. You promote mainly the gender diversity in the Python community, and you provide a friendly network, support network for Python users, not only limited to Tunisia but also worldwide. Thank you all for being here, and I will let Abir introduce the group. Okay, fine.
Hello and welcome everyone to this session. First of all, I want to present myself. My name is Abir Barqi, and I'm the HR manager of Women in Engineering Affinity Group, Esprit student branch that belongs to Tunisia section. So we are Women in Engineering. It's a group with the aim to help little girls to get interested in the engineering field, and we are very honored to collaborate with you as well, PyLadies Tunis. So in this session, we will learn, in these sessions, we will learn the basics of data science with the help of competent trainers. And for that, we would like to express our sincere appreciation to our today's trainer, Mr. Hafedh Hichri. Thank you so much for accepting our invitation today.
Fabio. So, will I start?
Yes.
Okay. Good morning, everyone. My name is Hafedh Hichri, a computer science student and a co-lead in the machine learning department in GDSC ENETCOM. So, today's session, we're going to be talking about data analysis with Pandas and Numpy. Now, as you know, in computer science, we have to treat our data set and then pass it to the AI model. So in order to process our data, we have to go through some steps. Those steps are almost repeated. Sometimes we get a data set that's not cleaned enough. So we have to explore it and then clean it. Now, first of all, I'm gonna start. Our main tools today are Pandas and Numpy. Strictly speaking, we're gonna be using Pandas, but Numpy arrays are a part of Pandas. Now, when we start our program, we have a data that is saved in our PC, but we're going to be working in a Python environment. So we're going to be importing our data from our PC into our program. That's when Pandas come into motion. So Pandas is a tool that imports our data from our PC or the cloud or anywhere into our Python program. And then we're going to handle it using Pandas too. So we're going to be passive. So to load the data, first of all, we're going to be loading the library, which is the tools we're going to be using, then load the Python file into the code. Okay. So import our library, we're going to be using the command import pandas as PD. Import pandas as PD is the code that brings the library into the Python file, but we did not import the dataset from our PC into the program yet. So to read the data from the PC into the program, we're going to be using pd.readcsv. pd.readcsv allows us to read the data from the PC into the Python program. Then we're going to just check into the data using df.head. We're going to check the first 5 lines of our dataset using it. Then our data, if it's tabular data, if it's an Excel file or a CSV file. What's an Excel file? What's a CSV file? You remember in SQL, you used the command create table something. Remember that? So in SQL, you used create table. So you created tables. So the data set that you created in SQL are tabular data. So to select a column from that data, we use the command df, which is the data, the variable that contains our data set, and we give it between brackets the name of the column. Okay.
Hafedh, maybe it would be nice, yeah, to share the code and to start sharing the screen.
Yeah.
With the code. Yeah, thank you.
Okay. So first of all, this is Colab. Colab is
You
a
are not
Python
able
environment.
to see your screen yet, by the way. Sorry,
Hmm?
you are not able to see your screen if you are sharing your screen. Sorry for interrupting you.
My bad. I thought I was sharing.
No, it was not shared from the beginning, by
No,
the
it
way.
wasn't.
Bad.
Okay,
No
no
worries. It's okay. We put in the chat the link to the collab. So please,
Okay.
you have the link. Go ahead.
Let's go back.
Okay, and you have nice slides also.
My bad. Okay. So Pandas is the tool that allows us to import the data from the PC or the cloud into our program. Okay. Now, using Pandas is going to allow us to import our tabular data into the program. And then we're going to handle it using Pandas too. Numpy comes into motion while using Pandas when we use subsequences, or we're going to use the df.value. We're going to go through that later. Okay. Import our data. First of all, we're going to import our tools like Pandas. We're going to import Pandas, which is the tool that allows us to manipulate our data. Then we're going to import the data from the PC into the code, into the Python file. Okay? Yes. Then you remember in SQL, you use the command create table. No? Okay. Create table allows us to create tabular data. So in this session, we're going to focus on tabular data. So to select one column from that data, we're going to use df between brackets, and we give it the column name. There are several ways to select one column or several columns. So we're going to pass into the code because I like to get into motion. Yeah. Okay. So this, okay. So this is Colab. Colab is a Python environment that allows us to use our code inside the cloud. Colab gives us 16 gigabytes of RAM and gives us the ability to use CPUs, GPUs, or either TPUs. Okay. So first of all, we're going to put our data inside the Colab file. Okay. Not into our Python file yet, just into the Colab file, into the cloud. To do that, we can either use this button over here and import our data from the PC into the cloud. Okay. So, okay. So I've imported the file, which is our dataset from my PC into the cloud. There is another way to do that, which is to use the git command. To use the git command, we just have to say git clone, and we give it the GitHub repository. So if we use the GitHub command in here, just downloads an entire GitHub repository into the Colab file. So we just have to refresh, and as you can see here, it added a file in here. But in this demo, I just have to install the data from my PC into the Colab, just to show you that there are several ways to do that. Okay. First step is to import the pandas, the entire library. So to do that, I'm going to use the import command, import pandas as PD. So I'm going to use the library pandas with the alias PD. So if you see PD, we're going to be talking about pandas. Okay, then next step is to load the data from the cloud into our Python file. Okay, so I'm gonna store our dataset inside of a variable called df. You can choose any other name you want to. You're not restricted with any name in here. So to import the data from cloud into Python, we use the command pd dot read csv. Okay. Then we give it the name of the file. In here, it's called home data.csv. Okay. Home data.csv. After that, we just have to check on our data. What does df contain in this moment? So we do df.head. In df.head, we just see the first 5 lines in our dataset. As you can see, there are multiple columns in here. The ID, date, price, bedrooms, and so many others. Okay? So we pass. We have imported our data into the code. Now we're going to do something else, which is explanatory data analysis, also known as EDA. Okay. What's EDA? EDA is the process of exploring our data. To explore our data, sometimes our data can be messed up. So sometimes our data can contain missing values or illogical values or values of type string. We have to clean up this data. So first of all, we're going to check if any of these are contained in our dataset. First, we're going to check on categorical columns. Categorical columns, also known as string columns. Example, name, or the village, or the country. Country names, also of string types. We're going to have to clean up those columns later. To check up on categorical columns, we just have to use the command df.info. We just have to use the command df.info. In df.info, we can see multiple information in here. Okay, just gonna use it in here, and then df.info. Okay, in df.info, first of all, we have the column ID. You remember that? Okay, the column ID contains 21,613 data, 13 lines of data which are full, also of type integer. Okay, if it's of type integer, so it's okay. The column date in here, it's of type object. Object columns are of type string. We have to clean up those columns later or to drop them. The choice is yours. Also, column price. The column price is of type integer. Price of the houses. Our data set in here is talking about the prices of some houses sold in America. So our target in here is to create an AI model that from some information, how many rooms does this house contain, how big the house is, we have to predict the price of the house. Okay, how much was it sold to, how much was it sold for. Okay, so as you can see here, all columns are of type integer or float, except for this column, which is of type object. Object columns are of type string. We have to clean up those columns or drop them. The choice is yours. We can also access the data description using Pandas too. You can easily use the command df.describe. df.describe gives us how many non-null lines in our dataset are existent. It means how many lines of data that are full. Example, what if someone filled our data and forgot to fill one column of it, which is a non-value? So if there is non-value, it's gonna be saying in here 21,612 if only one missing value exists. Okay, so we pass. This is a count. Also the mean. The mean is example in Arabic. No, okay. The mean of age. The age mean in Tunisia is about 50 years old, 60 years old. Okay. The standard deviation, also known as variance. The standard deviation is the difference between the maximum value and minimum value, and in a long term. It's a long formula. I don't have it in here, but we're gonna be talking about it in other sessions. Okay, so in each column we have the minimum value. Example, the minimum price of those sold houses. Example, the least priced house that was sold was 7.5 to the power times 10 to the power of 4, and the maximum value of a house that was sold is 7,700,000 dollars. Okay, those values 25, 15, and 75% are the quantile. They're not important in this moment. We're going to be talking about them in depth in other sessions. Okay, so to access our description, we use the command df.describe. Okay. Yes. Okay. Missing values. Missing values. What are missing values? Missing values is when someone fills a line of our data and forgets to put some information in it. Example, someone went to the hospital and he did not he did not write his name, or he did not write how old is he, or he did not do the blood test or sugar test or anything, did not give a simple one information in our data set, okay, on his line, on the column, on a viewed information, okay. So to see if our dataset contains any missing values, we use the command df.isNA.sum. df.isNA allows us to see if that value, if that information is of null type or not. Also, just a second. It tells us if this one is null or not, if this one is null or not, if this one is null or not. They're filled, so they're not null. Dot sum tells us that there are 0 null values in our data, okay?
Hafedh, I'm sorry for interrupting, but someone asked a question. Ahmed Amri said that do missing lines occur when the data set is set to not null, or it can happen in general?
Okay. Okay. This is our data set. ID, date, price, bedroom, bathroom. Imagine if someone sold a house and he did not give how many bedrooms that existed. So this one that I've just deleted is a null column right here. So example, if I delete this one, this is null too. Now imagine if someone, when he was creating data, he just forgets about one information, and he did not want to drop it the entire line. He just had to give it to us, and we as experts will have to handle it. Okay? We either drop the entire line, or we can either fill it with a number from us. Example, bedrooms, normal houses, example, okay, just. Most of the sold houses have 3 bedrooms in them, okay? Most houses that were sold have 3 bedrooms in them. Some houses have only 1 bedroom. Some houses have 4 bedrooms. Some houses have 2 bedrooms, which is normal, okay? Some houses, only 3 houses have 10 bedrooms in them. Imagine that. It's a castle, not a house. Okay. With us, okay. So we said if someone forgets to write an information, it means that this one is null, okay? We're gonna check if there is any null values in our dataset. So df.isNA.sum allows us to check if there are null values on each of our columns, okay? We pass. Outliers. What are outliers? Outliers are logical data in our column. Okay. Example. Imagine if you're writing ages, the age of someone. Okay. Humans cannot exceed 120 years old. Imagine if someone mistakenly typed in the age a number called 1915. You just mistakenly wrote it. It's a mistake from the user. Okay, we have to check if there are any illogical data in our column. So, and we're gonna handle them later. Okay. So, to check for outliers, we're gonna use the command df, and we give it the column name. Then we type box plot. So, we pass into the code. df example, we're gonna use the column price. Box plot. Now in here, you can see the distribution of house prices in here. Okay, most of our houses cannot exceed $1 billion. Some of them are sold for $7 billion, which is kinda weird for a house to be sold that way. It's overpriced. It's an illogical house price. We have almost 98% of the houses were sold under $1 billion. Okay, 98% of our houses were sold under $1 billion, and some houses were sold for $7 billion. That's an unimaginable house price jump in here. Okay, so illogical data in here are some houses are overpriced. We have to delete the entire house price from our data. We're gonna have to delete the entire line. Okay, some lines are about to be deleted in here. So I'm gonna handle them later. Just wanted to show you that there are sometimes some illogical data in our data set. Okay, then okay, just had to zoom in here. So most of the houses, as you can see in here, this is a box. This is where most of our data are localized, are inside of this box. So most of our data are localized in here. They cannot exceed $1 billion in here. And this is $7 billion. When you see IE to the power of 6 in here, we mean 10 to the power of 6, okay? After we explored our data, we have to clean it up, okay? Clean up our data. We can go through several steps. Either fill our missing data, deal with categorical data, which are columns of type string. We can deal with outliers. We can deal with too many stuff, but we're not going to be talking about them in today's session. Okay, so we pass. So to drop useless columns in here, example, what's a useless column? Imagine if we're talking about someone is sick or not sick. Yeah, someone is sick or not sick. So in our data, we have someone's name, someone's age, blood, and either sick or not sick, okay? The name of that person, does it influence his state of either being sick or not sick? Names do not influence our data set. They do not influence our observation in here. They are noise columns. Noise columns are to be dropped, okay, strictly speaking in here. So we pass. So in this example, we have to drop the ID, which is the identity In Tunisia, we just have to call it CN, carte d'identité. Okay, so we're going to be dropping the ID column and the date column. Why are we dropping the date column in here? We're going to be dropping the date column because it is of type string. Also, it contains too many unique values. Okay, so first of all, I'm going to be dropping the columns. Which columns? The ID column. Also, I'm dropping the date column. Yeah, okay. I dropped them, but I did not change the original data. I just used our data, took a copy of it, and deleted some. I deleted the ID and date column in here, but I did not change the original data yet. So to change the original data, you just have to specify the hyperparameter in place equals true. Okay. If we check our data in here again, how do we check our data? Using the command df.head. df.head allows us to check our the first 5 lines of our data set. You remember we used it earlier in here. Okay, right in here. This is df.head. Okay, so you remember there were 2 columns called ID and date in here. So I dropped them in here. They do not exist. They do not exist anymore. We pass. So today we're going to be using something even more complicated. We're going to be dealing with outliers. As we said earlier, logical data are to be dropped. There are noise data in here. So noise data, logical data, we're going to drop them. Okay. So to do that, first of all, we're going to select the df.price column because our subset in here is the price column. Okay. So we're only going to retrieve the values, the lines. This is our data. We're going to retrieve only the data here and there where the price does not exceed $2 billion. Okay. Any house above $2 billion, we're gonna be overlooking them. Okay. So that's a cap I've created myself. You can either specify $2 billion, $3 billion, $1.5 billion. The choice is yours. Okay. So 1, 2, 3. Okay. Oh my God. Okay, he said true, false, true, false, true, false. I did not drop them yet. I just only selected them. I selected only the lines where the price does not exceed $2 billion. So second step is to select the entire data set where the price does not exceed $2 billion. Okay, but I did not change yet. Apply our changes into the original data. We specify df equals this entire thing. Okay. And check. Okay. df of price of what? So I dropped most of our illogical data in here. Any price above $2 billion is to be dropped in here. Okay, this is one way to do it. So we're gonna pass. Next step into our program. Now we are preparing our data set to give it into the AI model, into the AI program. Okay, so the next step is to split our data into the target column and the features column. Okay, what are targets and what are features in here? The data set in here is talking about the prices of some houses. We're going to be building an AI program that from the number of bathrooms in this house, from the number of bedrooms in this house, from the square foot lot of this house, we're going to predict the price of this house. Okay, so from the features, from the conditions, we're going to predict the price. Okay, so next step is to split our data into the features and the target. Okay, just have to read into your program first, read into your data first, then we pass. Okay, so to select a column, there are multiple ways. Either use df and the name, or df with double columns and that name, or df.lock, and we give it select all the lines in our data and only bedrooms. Or there is also another way to do it, which is iLock. iLock, we use the location of that column. Now bedrooms is, this is the 0th column. Okay. If.info. Price, we can refer to price with the number 0. Bedrooms, we can refer to it with the number 1 in here. Bathrooms, we refer to it with the number 2. Okay, so if we use iLock and to select the bedrooms is ranked 1 in here. Okay, so I'm going to use the number 1. Okay, so in here just had to show you there are multiple ways to select our data, but we did not split our data yet. We're going to split our data into the features and the target, the price in here. Okay, so to do that, I have to select our data where I'm going to select every line in our data. That's where the 2 dots in here come in place. Then I'm going to tell it to select from bedrooms. Okay, I'm going to tell it to select starting from bedrooms until bathrooms, going to square foot living, square foot lot, floors, waterproof until the end. Okay, I'm going to select the entire data set in here except for the price. Okay, from 1, which is bedrooms, until the end. Okay, so to do that, we say df.ilock. In here we say from 1 until the end, 2 dots. To run our code, we just have to click on this in this bottom in here. Okay. So we selected our every column in our dataset except for the price column in here. Okay, but I did not save it in a variable. Then I'm going to store this inside of a variable. I'm going to call it X. You can either call it X, A, B, Y. The choice is yours, like I said. So I'm going to call it X. Okay. I've stored our data in X. X contains what? To check into X, use the command .head again. Okay. So X contains the bedrooms, bathrooms, square foot living, square foot floors, everything except for the price, like we said earlier. So to store our price into the next step is to store the price into another variable. I'm going to call it Y in here. Okay. So I'm going to select the price and store it into Y. Okay. To run the code, you just have to press this button in here. Okay. And it's done. Okay. So we imported our data, we split our data, we cleaned our data, we visualized our data. So, okay. Next step is to see if there are columns that have really big variation in their values in here. Okay. So to do that, I'm going to select the entire data set in here. Okay. And I'm going to use boxplot again. Okay, this is gonna be hard. Okay. Forget about this. So first of all, I'm gonna be importing the libraries that I'm going to use, which are matplotlib. So first, I'm going to import matplotlib.pyplot as plt. Run the code, pass into the other cell. Okay, then I'm going to say df boxplot mplt.xx rotation was 90. Don't have to memorize this code, okay? You don't have to memorize this code. Just cleaner code, okay? So as you can see in here, the variation of our columns in here. What can we see? You can see the price is varied from around 0.1 in here until 2 billions in here. Okay. Also, the square foot lot in here is really varied in here, which is from 0 until 1.6 in here to the times 10 to the power of 6. Also, the square foot lot 15 is also varied in here. So the next process, you have to either transform the data, which is we're going to okay. First of all, I'm going to select the maximum value of the price. The maximum value is around 2 billions in here, okay? So I'm going to scale the data. I'm going to minimize our data from 2 billions into a lower value in here, okay? Or we're going to minimize our data, scale our data from using either the max, either the min, either using standard scaler, either using min max scaler, either using the standard, either using the mean value of our data, okay? The choice is yours. Okay, I'm not going to do that in here, which is going to take too much time, but I'm going to show you other features that are used in Pandas. Okay, Pandas also comes with some features like using the dot columns in here, df dot columns in here. What does it do? It gives us the name of the columns in our dataset. Okay, price, bedrooms, bathrooms, square foot living, square foot lot, floors, waterproof, view, condition, grade, latitude, longitude, square foot living, square foot lot. This is every column in our dataset, okay? There are multiple, okay. We can also use some other tools like the plotting types like so in our data, we're going to check for how many bathrooms in our data they exist. Okay, so just a second, the code's gonna take a little bit too long in here. So until then, I'm going to ask some questions. So how do we import the data? Someone opens the mic, please. How do we import the data from our PC into the code, to our code in here? Using which command?
Read CSV.
Yeah, exactly.
Yeah.
If we use pd.readcsv, we
Yes.
import our data from the PC into our Python program, okay?
Yes.
Yeah, this code is taking too long. Oof. This is why you need a stronger PC. Okay, this is weird. So value counts shows us the distribution of our data in here. Some houses, most of our houses have 3 bedrooms in them. Some houses have 4 bedrooms in them. Some houses have 2 bedrooms in them. And one house in our dataset contains 33 bedrooms in it. Okay, that's kind of odd, okay? You gotta clean up this value in here later. You can use the other formula that we used earlier in here. This one. Okay. And we specify the maximum value of the bedrooms that we use. Okay, this is taking too long. Okay. So to summarize, this is the cleaner code that I've sent to you. Okay. First of all, we run our code. It imports the dataset from GitHub into the Colab file in here and stores it in here. Then we import pandas into the program. Then we import our data from Colab, from the cloud into the Python file. Okay. Then we check our data, df.head. Okay. Then we check for informations about the data using df.info. When we see our informations in here, we can see that there are some columns of type object, which are categorical columns, string columns. We drop them or we encode them. Then we check for missing values in our data using df.isNA.sum. Then we see the distribution of our data set using the command df, and we give it a column .plot. Then we see the description of our data set, like the mean or the standard deviation or the maximum value of each column. Okay. Then we're going to drop useless columns like the ID using df.drop. Then we're going to drop the outliers, the illogical data, using this command right here. Okay. After we drop the outliers, the illogical data, just have to check on the max. The new maximum data in here does not exceed $2 billion. Okay, we can check the distribution again if we want. It does not exceed $2 billion. This is weird. Okay, I guess this is it for today. Thanks for coming. I hope you enjoyed today's session. If you have any questions, you can contact me or the IEEE board members. I'm going to be sending you some sites where you can work on them. You can get certified online from them, like Coursera, DataCamp, DataQuest, Kaggle, Solr. You're gonna need these ones. I'm going to send them later. And I hope I see you again the next one.
Thank you so much, Hafedh. It was really nice having you with us today. I don't know if you can see in the comment section, but everyone is thanking you for this wonderful session. We learned a lot. Thank you for your efforts. Thank you for your time, and we hope we see you with us again in the upcoming events.
Yeah, thank you so much, Hafedh, for sharing this your knowledge within our communities. For Erigius, we will share later the recording video on the YouTube channel. I will share with you the link now. Okay, so and we sent an email later. So I will share with you also just my screen again. So tonight we'll also be hosting Laura. So she will animate a workshop about how to create a dashboard with the Dash library in Python. I will share with you the link now for registration. Everyone is welcome to join us. Okay, this is tonight at 8 p.m. This is for Tunisian people, 8 p.m., but you should see according to your time zone. Okay, I will share now with you the link. Just I'll stop sharing my screen first. Yes, fine. Okay. Okay, this is the link to be able to attend tonight's session. Fine. Okay, have a nice day, everyone. Goodbye. Thank you,
Thank you.
Hafedh, again.
Thank you so much, guys. Have a nice day.
Have a nice
Goodbye.
day. Bye.
Bye. Have
Goodbye.